This video will start by giving you an understanding of what molecular and empirical formulas are, and I will then show you how you can answer questions over this topic in your chemistry class. Let's get started. First of all, don't make the mistake I made and go 17 years of your life without knowing how to spell empirical. It has two I's in it, one after the P, one after the R. So, we know that the smallest building block in chemistry is the atom, but rarely will we see just atoms existing by themselves in nature. This is really only the case for the noble gases, which already have full valence shells. For most, that means a full octet, though helium is stable with just 2 electrons. Other elements, and by other elements I mean every single other element than noble gases, will form compounds in nature to be as stable as possible. For example, oxygen gas isn't just a single atom of oxygen. Rather, it's 2 oxygen atoms, O2. So, we've established that elements will form compounds to be stable. When describing the chemical formula of a compound, there are two different notations we can use. We can use the molecular formula, which is the precise ratio of atoms in the compound, or we can use the empirical formula, which is a simplified ratio of atoms in the compound. Just to show you a quick example of this, the molecular formula for fructose is C6H12O6. But these three numbers, 6, 12, and 6, share a greatest common factor of 6. So if I were to divide each of them by 6, I could rewrite the formula for fructose as CH2O. That would be the empirical formula of fructose. The ratio of the atoms to one another has stayed the same. There is still twice as many hydrogen as there is carbon, and there is still half as many oxygen as there is hydrogen. But we've simplified it to the lowest possible terms. Now that we know what empirical and molecular formulas are, let me show you how to solve these types of questions. So let's say we have the following question. A compound is found to contain 40% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. What is the empirical formula of this compound? Well, to solve all empirical formula questions, we use this really handy rhyme, and it goes percent to mass to mole, divide by small, multiply till whole. These are 4 different steps which we will be doing to solve the problem. Step 1 is percent to mass. We take the percentage of each of our elements and just turn it into mass. So 40% goes to 40 grams, 6.7% goes to 6.7 grams, and 53.3% goes to 53.3 grams. Next, we need to change the mass to mole. To do this, we just set up an easy stoichiometric conversion. If you don't know how to do this, I have a full video over that on my channel. The molar mass of carbon is 12 grams per mole, which gives us a final answer of 3.33 moles. We will do the same step for hydrogen and for oxygen. Now we go on to the third step. We divide all of these numbers by the smallest number. The smallest number is 3.33, so we will divide all of these numbers by 3.33. This will give us a value of 1 mole for carbon, 2.012 moles for hydrogen, and 1 mole for oxygen. The final step is to multiply all of these numbers until they are whole numbers. However, if you take a look, 1 is obviously a whole number, and 2.012, well, that's pretty much a whole number. We're not going to multiply that out. We can just pretend that's a whole number. Same with 1, that's also a whole number. So the final empirical formula for this is CH2O. And hey, look at that. That's the empirical formula for fructose. So that's how you would solve empirical formula questions. You would be given relative mass percentage of different elements, and then you would just have to do these rhymes. All of these questions will look similar to one another. Let's do one more of these questions just to make sure you've really got it down. Let's say we have a compound that is 70% iron by mass and 30% oxygen by mass. All right, remember our rhyme, percent to mass. We're going to take each of these percentages and turn it into grams of that element. Our second step is mass to mole. We're going to take each one of these values and set up a stoichiometric conversion. Our third step is to divide by the smaller value. In this case, that would be 1.25. Dividing each of these by 1.25, we would get 1 mole of iron and 1.5 moles of oxygen. The last step is to multiply until whole. To do that, we would just multiply it by 2, since 1.5 times 2 is 3, which is a whole number. We would have to do the same to our iron. This would leave us with 2 moles of iron, Fe2, and 3 moles of oxygen, O3. Alright, congratulations. You now know how to solve empirical formula problems. Let's move on to the molecular formula. Solving molecular formula problems is actually a lot easier than solving empirical formula problems. Let's say we have the empirical formula for a compound, CH2. and we are told that it has a molar mass of 84 grams per mole. Well, to solve this problem, there's really only two steps we need to do. We need to find the molar mass of the given compound in its empirical formula, and then divide the actual molar mass by that value. For instance, carbon has a molar mass of 12, and hydrogen has a molar mass of 1, but we have two hydrogen atoms. Adding this up gives us 14. Now, we just take 84 and we divide it by 14, which gives us a final answer of 6. So what we know is that we've reduced the molecular formula 6 times to get this empirical formula. So let's just take this and multiply it by 6 to get back to our molecular formula. Doing so would give us C6H12. And that right there is the molecular formula. Congrats! You now know how to solve molecular formula problems. Pretty easy, right? Oftentimes, you will see a combination of these two problems. You will be given the percentage by mass of different elements, and then told the final molar mass of the compound. First, you will have to find the empirical formula of the compound using the rhyme, and then you will have to convert it back to its molecular formula using the process I just showed you. Both of these steps are simple, but just make sure you're really thinking about it and not leaving anything out. I hope you have a stronger understanding of molecular and empirical formulas after having watched this video. If it's not making sense, try rewatching parts of the video. If you're still not getting it, just take a break and come back later. Thank you for watching.